and begin our note taking. This direct variation. Okay, go ahead and fill in your information. So fill in your name. Today is January the 7th, and this is period 1. So direct variations are special types of linear equations. So that's why we're doing that in this unit, is it is application of the lines that we've been discussing that show a relationship between x and y. Okay? You can decide if a line is a direct variation if it passes through the origin. If a line does not pass through the origin, it cannot be a direct variation. What is the origin? 0, 0 is the origin. So if you need to make a note of that, this would be a good place to do that. So, if you're watching the video, pause it for a second and see if you can tell, right, yes or no for questions 1, 2, 3, and 4. Are they a direct variation or are they not a direct variation? Okay, hopefully you had a chance to answer those questions. Number 1 was a direct variation. Is number 2 a direct variation? No. Is number 3 a direct variation? Yes. Is number 4 a direct variation? No. Does not pass through the origin. Origin is right there. So if it does not pass through the origin, it cannot be a direct variation. Okay? So, let's look at the equations of these. In the equation, if the equation is a direct variation, the y-intercept, b, is always 0. In other words, if you have y equals something times x plus b, b is always 0. If it is a direct variation, b must be 0. Therefore, the equation for direct variation is always y equals, now I'm going to write a k because all of your math textbooks call the variation k, but k is the slope. Okay? But when they're talking about direct variation, they say k. So this is the same thing as m, but when they're talking about variation, they call it the rate of change, or k. Okay? So k and m are the same thing. Direct variation is the slope. Okay? In direct variation, k is the slope. Where k is the slope or constant of variation. Okay, so let's look at some equations. So we're looking for 2 things. They need to be a line, and they need to have a b of 0. And it needs to be something times x. Okay? So let's look at a couple that are direct variations. You could always graph the line if you need to, because you all told me up here that you know, looking at it, if it's a direct variation or not. Okay? So if you need to graph these, plug these into your calculator and graph them. So is this one a direct variation? Yes. How do you know? Because k is 2 and b is 0. It is the equation of the line that goes through the origin. Okay? How about number 2? No, that is a line that looks a little like number 2 up here, except it's horizontal at 2. It goes through this piece right here on this one. Okay? How about number 3? Is that a direct variation? Yes. It's negative, the k is negative, and that's okay. K can be negative. K is -1 in this case. Okay, but it does go through the origin, doesn't it? Okay, and b is 0, so this is a direct variation. Okay, how about number 4? No. Why? Because b is -2. B is -2. It does not go through the origin. All right. Please try and work 5, 6, 7, and 8. I'm going to pause the video while you do that. Okay, so is number 5 a direct variation? Yes. Is number 6 a direct variation? No. Number 6 is a line that looks like this. If I'm graphing this line, it is a line right here, up and down at 4, isn't it? So that is definitely not a direct variation. Not only does it not slant, it doesn't go through the origin. Okay? What about this one, number 7? No. What about number 8? Yes. Okay, great job. Direct variation is easier than inverse variation. Okay? Now, again, the word problems are a little more difficult because a lot of people get lost in the wording, but let's not do that. Assume that we have a direct variation. Okay, when you see that word, you should say, okay, B has to be 0 so that it goes through the origin, and it has to be a line. That's what that should mean to you. And if we have a direct variation, if y equals -12 when x equals -4, we can calculate that, because remember I told you it was y equals some direct number times x, or y equals mx, if you will, right? Okay? So all I'm going to do is to plug these two values in and find the direct variation, find the slope. So plug in y is -12, and x is -4, and I can find k. What is the constant of variation? It's asking you for the slope. Okay? So highlight this, if you would, or underline it. The constant of variation is the slope. The constant of variation is the slope. So they're asking you to find the slope. That's what they're asking you to do. Constant of variation is the slope. So take a moment and find k. You should be able to solve that. K is +3 because a negative divided by a negative is a positive. So the constant of variation for the slope is 3. All right, you try number 2. Okay, let's see what you got. What is the constant of variation? Did you get 24 equals k times -3? So what is the constant of variation? -8. Excellent, excellent. Now, these are new terms. So if you don't know what a constant of variation is, constant of variation, that is the slope. What is the constant of variation? The slope. You guys wake up. What is the constant of variation? Okay. All right, let's go on to page 2 then. And let's talk about the other topic that we need. The other topic is inverse variation. Now, this one to me is a little more challenging, but they're not going to ask you a whole lot about inverse variation because it really doesn't fit in Algebra 1 as much as in Algebra 2 and the other courses that you're going to take in the future. But it is kind of connected to direct variation. So an inverse variation, as one variable compares to the other variable. So and the inverse is x and y. Again, But this time, inverse is the same as reciprocal. Okay? So I'm going to turn it upside down. So this one is going to be y equals k. Remember, k is the slope, divided by x. Okay? Inverse, reciprocal, flip it upside down. So that's what I'm doing here. So this is the graph of an inverse. The graph of the inverse variation does not pass through the origin. It never passes through the origin. And it's also a curve. Do you see that that's not a line? This is a curve. Okay, so you see if they say the words inverse variation, it's going to look like this. And it's going to have this division in it. Okay? The only problems they're going to put on the SOL for this are going to be word problems. So let's practice these word problems. So assume that y varies inversely with x. When you see the word varies inversely, you need to remember that you're doing y equals the slope, k, divided by x. So if you write that on your paper and then you fill it in, you're never going to miss this kind of question. Okay? So if when y is equal to 40, so y is equal to 40, and x is negative 16, x is negative 16, so equals k over x, over 40, sorry. Sorry? Yeah, just 16. So this is 16. Now, they gave you 3 pieces of information, didn't they? They want you to find x when y is equal to negative 5. Well, I can't find x if I don't know what k is. So I have to first find k, so this is a lot of substitution. So how do I find k? Multiply by 16. So if I multiply by 16, I'm going to multiply this side by 16 and multiply this side by 16. So k equals, what's 16 times 40? 640. So the constant of variation is 640. Okay, so now I'm ready to start the second part of my problem. I know what k is because it varies inversely with x. And so now, to finish up my problem, I'm going to say y equals x, 640, that's right, divided by x. Because we're using that y equals k over x still because it's varying inversely. All right? Now I'm going to substitute this negative 5 in. 640 divided by x. Okay, so how do we do that? How do you solve that? I'm going to multiply both sides by x. And so it's going to be negative 5x equals 640. And now divide both sides by 5. Negative 5. Why negative 5? Just 5, not negative. It's not negative 5. Oh, yeah, it is. It's negative 5. So x is, how many times does negative 5 go into 640? Okay, so it's negative 128. All right. I think those are a little more challenging. What do you think? Are those a little more challenging because it's not quite as linear as what we've been talking about? try another one. Let's try number 2. You have to substitute and substitute again. So again, this is going to vary inversely. So if we're varying inversely, that means I'm going to use y equals k over x. So the first step is to find the constant of variation, find the slope. And then the second step is to find y when that slope is the same thing. Do you understand what we're doing? Okay, so in the first one, y is 7 and x is -4. So multiply both sides by -4. The constant of variation is -28. Now I'm going to use that same constant of variation, that same slope, to do this one. So I'm going to find y when x is 5. So it's -28. That's my constant of variation over 5. So 5y equals -28. Then y equals -28 over 5. You can leave it like that because it's simple. I know a lot of you are going to want to turn that into a decimal, and you can. What is it, 5.6? If you turn it into a decimal, -5.6. Okay, you try one. Step 1, find the constant of variation. Step 2, use that constant of variation to find the missing variable. So the constant of variation was 20, and y is 5 when these vary inversely.